Okay, so the second half of chapter 10 in our text, we talked in the first half about fraud and the potential for crime. We talked a little bit about internal controls associated with accounting systems. Now we're going to really talk about internal controls associated with technology. And when you think about internal control, it's not all about fraud. It's not all about people doing illegal things. You also have internal controls just because people make mistakes in this world, and you want to minimize the impact of mistakes. So it's not all about people being nefarious and doing illegal things. We'll talk about 4 different categories of controls in the IT world. Organizational controls, controls within the hardware and software environments, specific controls that you need because of the e-business world we're in, and then controls that you actually put in your software, put in your programs as you write them. The reason you have IT controls, you want to secure your environment, you want to make sure it's available 24/7 or whatever you need with very little downtime. Bloomberg was down last Friday for all the trading floors. That's tough on Bloomberg. Controls come in 3 categories. The first is preventative controls. Preventative controls will either stop a process before a problem happens or while it's happening so that an error does not actually occur. Examples of preventative controls could be in the accounting world, segregation of duties, so that you prevent fraud by having 2 people sign off on something. Another preventative control could be a lock on a door. Whether it's a data center or this room, prevents people from stealing computers. That's a preventative control. Passwords to restrict access prevents the wrong person from coming in and doing something they shouldn't do. And then real-time transaction validations. You type something in, it's wrong. Let's say you type in the wrong credit card number. It comes back immediately and says that's not a real credit card number. It prevents you from putting in a transaction with the wrong credit card number. Those are all preventative. They stop a problem before it happens. The best kind of control if you could do it, right? The cost is the smallest. Second kind of control is a detective control. These are controls that are in place to identify where a problem might have happened. You might have exception reports that come out that show that there might be things that happened during the last day that were unusual. We should check on them to make sure that they aren't a problem. They detect a problem. Reconciliations, physical inventory. So that's an after-the-fact control to see, do we have as many dresses in the dress department as our system says we have, because there's always the risk of pilferage and loss in other ways of inventory. Auditors, are internal and external, are a detective control. They come in and they try to find problems that might have occurred. So these are after the fact. The problem has already occurred. That's not where you want to find the problem. You want to find the problem before it occurs. And then corrective controls. These are controls that are in place to fix a problem after it's occurred, get everything back to normal. You have backup files. So if you have corruption in your primary file, you can use your backup files to get your data back, hopefully to the point of where it was before. UPS, uninterruptible power sources. Backup power in case you have a power outage. Hospitals need to have these, right? And if you do have them and you're in lower Manhattan, you probably don't want them in the basement, which is what happened with Hurricane Sandy. And they got flooded. And discrepancy reports, these might be corrective, they may be detective. Okay, so let's talk about some controls. They fit into 2 categories. There are general controls that are throughout the organization, and there are application controls which are inside of each of your various application packages. We'll talk about both. Starting with the general control for organization. How does an organization manage itself to minimize problems. Starts with philosophy and style. How do you manage risk? What's your perspective towards risk within the organization coming from senior management? What's your perspective towards adhering to budgets at all costs? If you force people to adhere to a budget at all costs, they'll tend to cut corners. They'll tend to lose control. What's your tolerance towards mistake? Organization structure. How do you organize so that you plan, execute, and control? Do you have an internal audit department that reports up to senior management so that they have more free rein to do what they need to do, without feeling pushed back by the organization? Does your organization focus on integrity and ethical values? You want to make sure that people are not incented for dishonesty. How committed are you to only hiring the very best people to do a specific job? Make sure that the board of directors and your audit committee have independence from your CEO, that they're able to provide a second set of eyes or a third set of eyes for what the organization is doing at the highest strategic level. And that you have clear lines of responsibility and authority. So these are all organizational controls. And then within HR, policies. Do you do background checks, bonding of personnel? Make sure that they are appropriate for what they're doing. If you're a bank, do you rotate duties of the teller, get them out of the teller function, so if there's a problem, you might be able to find it. Same thing with mandatory vacations. Do you make sure that everyone trains 2 weeks out of the year or something of that kind? And do you reward the right activities and the right way of being rather than the wrong way of being? It starts with IT governance. We talked about that when we talked about the systems development lifecycle. The purpose of IT governance is to align IT with the corporate strategy, to make sure that the people with IT are assigned appropriately to implement the corporate strategy. That involves prioritizing the efforts that they're doing. And then you stay in it. You develop, monitor, and review policies and security. And security is more and more important. So this governance committee, which is usually a C-level committee, it'll be the CIO and the CFO. These are people senior in an organization who may not be well versed in a lot of the IT functions, except for the CIO. They need to understand how important it is to stay on top of this stuff. The risks are too great. We talked about segregation of duties as it relates to the accounting function. You want to segregate duties there, but you also want to segregate duties within the IT function. You want to make sure that IT is somewhat separate from its users. You don't want to be so far separate that the IT department just builds things because they think it's cool, which is a risk you take with IT departments. They like new technology and they want to play with it. But you want them to be segregated, because if you have a user group that has their own IT department, and I've seen this, they don't believe in internal controls. They just, this isn't like a trading department for an investment bank. They just want to get their models out there and get them working and try to make money with them. But if they're buggy and they're not controlled right, you can lose millions of dollars. So you want to have a separation between the IT function and the user function to some degree. So there is a check and a balance there. Even within IT, you want to have separate functions. You want a different person to be a systems analyst than a programmer. The analyst designs the system, the programmer programs it. You want to have this programmer, kind of read the design and say, that's silly, that doesn't make any sense to me. You want a second set of eyes on that process to make sure that somebody is checking the analyst's thought process, because it's not always as logical as it seemed to the analyst at the time they wrote it. You want to make sure that the people testing a system are different than the programmers. Because again, the programmers program the system the way they think it's supposed to work. A tester, hopefully there'll be some users in that tester group, should be testing it the way they think it's supposed to work, and it may be different than what the programmer thought. And so you need to have a second set of eyes there. You need to have operators and database administrators who are separate from all of these developer types, who are just making sure that the needs of the organization as a whole are being followed. BCP, Business Continuity Planning. This is kind of in the detective world, right? This is after the fact. You want to make sure that you have a plan in place in case of a disaster. That's what business continuity planning is. How do you stay in business when there is an IT disaster out there? And companies that do it right will actually take a weekend every couple of years, not every year, but maybe every year, where they have a fake disaster over the weekend, and everybody in the organization, not just the IT department, mobilizes as if it was a real disaster. In the same way that you see police departments do it or whatever, companies need to do that so that they know that when a disaster happens, people are ready and trained and know what they need to do to get the business back up and running. Some of the things you'd have for business continuity planning would be redundant servers. So if your servers go down, you might have a second set of servers off-site somewhere that you can bring up to get running. Make sure you have backup of your data. Make sure you store your data somewhere, ideally in a separate power grid somewhere. Like, if you have all of your IT in the same power grid and the power goes down in that grid, you're doomed. So you think about, how do I set up a secondary source somewhere that's a separate power grid from the primary. Some of the components of a business continuity plan: disaster recovery, that's what I talked about. You want to know what you're going to do when there's a disaster. There are fault-tolerant systems. This is a term we used when we did the networking chapter. Systems that, if there's a smaller problem, how do they find it and fix it? And then backup. Those are the three primary components. You want to make sure that you locate your data processing center, your computer centers, where you keep all your servers and your mainframe computers, in safe places. Safe has two components. Are they safe from the public, and are they safe from natural disasters? So servers should be very difficult to get into. The server room should be very difficult to get into. Multiple locks. You'll need Tom Cruise coming in and getting over the laser beams or whatever they do to get into them. They should also be somewhat protected from natural disasters by having a backup site somewhere else. Don't put it in a high-risk area. Most computer centers, in case of fire, don't use water. Why wouldn't you use water if there's a fire in the data center? It'll destroy everything. So what do? They use a gas called halon, which essentially sucks all the oxygen out of the room. So you don't want to be in there when that kicks in. So you would want to have a halon system set up for your data center to ensure that if there is a disaster, like a fire or smoke or whatever, it gets put out immediately, but nobody's in the room when you do that. And you want to make sure that even if it is protected from the public, that you don't allow just anybody in. If you're a computer programmer at a major company, I don't know, JP Morgan, you should not have access to the data center. The data center is for only, you might get to go in there once in a while to look at it, but the data center access is very, very limited. And it will have cameras, and it will have all those things that you might expect a highly secure environment to have. So you limit the access, much in the way that we limit the access to this room a little bit. Disaster recovery, what do you do in case there's a disaster with all of your employees? Back in the day, you'd have a second site. Quite often, if you had, let's say, your primary offices in New York, you might have a warehouse up maybe in Connecticut. And all the employees knew in case of a disaster in New York, you go up to Connecticut to work. In today's day and age, you do that less and less because you're able to work remotely in a worst case scenario. Everyone can work from home on their personal computers. So it's a case by case. Some people need to work together, and so you might have that secondary site somewhere. That site could be a hot site or a cold site. They are or anywhere in between. This is a continuum between hot and cold. A hot site is one that's essentially a duplicate of your production environment, ready to go. Just flip a switch and it becomes your production environment with all of the technology you need to be up and running. A cold site, at the coldest sense, is just some desks and chairs. Let's go in there and figure it out together. And so it's there's a lot of, it's
gray area between the two. But those are the two ends of the spectrum, hot sites and cold sites. That's BCP. Fault-tolerant systems. Sometimes computers just do some weird stuff. You know, they just have a little blip. There's a problem. There's a piece of dirt on the hard drive on a server. So there are different approaches to fault tolerance. Fault tolerance is looking for a problem and then figuring out what to do if there is a problem such as that. And remember, RAID systems, R-A-I-D, that's a fault-tolerant data storage technique. We have multiple disks. The first approach is consensus-based. A consensus-based approach says you'll have an odd number of identical writes for every transaction, and you have an odd number because majority wins. So if you have three is a normal number. If two of them are the same and one is different, then the two that are the same are assumed to be correct, and the one that's different, you assume there's a problem. You would take that one offline. The other two would stay online as you figure things out, and you then would fix the one that was different for some reason. That's consensus-based. Watchdog, you'd have two. You'd have the primary and a second one that kind of repeats it, and if there's a difference between the two, you would report the difference out and try to figure out why there was a difference, but it's just watching. Disk mirroring or rollback. Rollback. It's a concept in technology, computer. Let's say you have a point-of-sale system. Let's think about all the things a point-of-sale system does. It charges the customer. It gets a price. It changes the inventory. Maybe it triggers a new inventory order. You know, at the moment of sale, a lot is going on. But what happens if you have a problem in the middle of that transaction? So it charges the customer, but it makes a mistake, and it doesn't decrement the inventory. Now your inventory is off. So what a checkpoint is, it says we could do all of this stuff towards our transaction while it's happening, but until this checkpoint is hit, nothing holds. So if you don't get to the checkpoint, everything rolls back to the beginning of that transaction like it never happened. So you don't have these half-completed transactions in your environment, because those are very risky. When your data gets all out of sync, it's very hard to get it back into sync. So a checkpoint environment is one that doesn't allow a transaction to grab hold until it's completed. Once it's completed, you have this checkpoint, and then it's true. It stays true in all senses. That's a checkpoint. Hardware control. Well, we know we got these little bits and bytes, right? One thing you might have in a hardware control is a parity bit. So a byte has how many bits? 8. One thing you might look for every byte is that it either, if you added up all 8 bits, they either be odd or they be even, it doesn't matter. So the first 7 bits are the data point, the character, and the last bit is a parity bit. And if they have to be even, and the first 7 were odd, then it would be a 1, because the odd plus the 1 will make it even. And if the opposite, if the other way was true. So a parity check just is one way of making sure that you don't have bad data coming through. It's either odd or even based upon what you say it should be. Another thing you might do is a dual read, which is exactly what it sounds like. You read the same data twice and make sure it's the same both times you read it. If it's different, you have a problem. An echo check, let's say you want to print something. You would send a message to the printer, I'm printing this. The printer would acknowledge the message and say, do you want to print this? And you'd say, yep, and then it would print it. So it's it's called an ACK for acknowledgement. You might see that term, an ACK. Controls for PCs. How many of you work for a company where they gave you a PC to use? How well was that controlled? How about the hardware itself? Did they know what you did with it? Generally speaking, the hardware they give you is relatively low risk, generally speaking. If you think about what we did last time with net expected value, you could put in a lot of controls to make sure you don't lose computers, but if you stole that computer, how much would the company lose? $1,000. The downside, but no, my point is the downside of one person stealing one computer is relatively small. So the controls they put around that is relatively low. I mean, they're going to control. They're going to put tracking numbers on, and they're going to, if they gave you a phone, it's the same idea. They're going to want to make sure that they know that that you give back the phone at the end. But it's not that big a deal for them. So this is an example where a company has to think about their expected value. Net expected value. Is the control worthy of the cost of the control? So they may control the computer. They may not control some of the peripherals that come with the computer. They definitely are not going to control it if they give you a second power cord, right? Because that's just not worth worrying about. Okay, now we're going to get a little bit more into the software world. Talk about a bunch of controls to make sure that only the right people are accessing the computers. So this is how they authenticate who's on the computer. First one everyone knows, login, right? You have to log in. Second is a user profile. This is usually part of the database management system. We'll see an example of this. We'll come back to it. Third is a smart card. Anybody know what a smart card is? This is a smart card, right? It's got a little chip in it. So it's something I have. So in theory, to get into this room, although it's often not locked, you have to have one of these to get in, and it has to be profiled through an authority table that my card is good, your card isn't. A security token. How many of you have used a security token? It's considered, we'll talk more about this, it's considered a two-factor authentication. Two factors usually have something physical and something about you. So the two factors here is you get a piece of hardware you put on your keychain usually, and it just has this, every 30 seconds a new number shows up. And two things have to happen. When you want to log into your system remotely, you have to type in that number while it's still fresh. It's only good for 30 seconds, and type in a password. So if somebody steals this thing, they don't know your password, so they can't get in. And if somebody does know your password, they don't have this thing, they can't get in. They have to have two things, something physical and something you know. And that's really the direction that all security is going. Even, look at what the the iPad has, thumbprint or iris controls, which is biometric devices. That's the thing. That's what you are. You are your thumb or you are your eye. Computer logs are after the fact. Video surveillance, that's back there in case you were curious. Firewalls. How many of you keep your firewall on your personal computer? You should, right? Prevents, to some degree, people getting in. And certainly, we'll talk about this a little bit more in terms of something called a proxy server that we'll talk about. And then encryption. We've talked about HTTPS. I'll try to explain it in a moment. Okay, so the authority table. You have 3 users. They have different levels of access. Maybe they have no access. Maybe they're allowed to add records. Maybe they're only allowed to update records. Or maybe they're allowed to delete or only read only. And so each user has a certain level of access to various different components of the environment. And this is usually controlled within the database management system to ensure that only the right people are doing the right things. And so when you log on, you are that person. So obviously they don't know if you're actually Beyonce. But if you log on as Beyonce's ID and password, then you're in. That's an authority table. Two-factor identification, a physical and a logical. And we'll see more and more of this over time. 2 pieces of identification that historically were considered really powerful are less and less being considered useful. Your social security number, because everybody knows it, right? It used to be, If you had your social security number, don't let anyone have it. But now it's your ID on half of your applications. So your social security number is less and less useful, and your signature. That's considered the worst way, because think about it, when you go to a store and you sign, you buy something, they ask you to sign. Who's checking your signature? It's a clerk, right? They're not trained in knowing whether your signature is real or not. So those two methods of identification are less and less useful over time. And so it's just, you have a physical and a logical method, and more we'll see those take hold. We talked about the firewall. We'll talk now about encryption. Security, there's WEP and WPA. These are wired and wireless. Those are kind of the protocols, and there's WEP2 and there's WPA2. We're not going to get too much into it. A virtual private network. How many of you have ever used that in a business world environment? A couple of you. Essentially what that does is, with special passwords, you could be at home and have your own private link to your company that nobody else from the internet can sneak in on. It's a more secure way to get into your company's data than simply going into it through the internet. It kind of gives you a tube between you and your company. Antivirus software, proxy service, I think I'll talk about it more in a moment. And then you have these assessments. Accounting firms do this. They, you hire hackers. It's good money in being a hacker. You hire hackers, and the hackers it's their job to try to get into companies for the use of good, not evil. And so you figure out how vulnerable a company is. And then you hope that the company can detect a hacker. And that's a vulnerability assessment. Encryption. So an encryption key is some mathematical function, I'll explain in a moment, that changes the data that you've entered into other data, that unless the receiving computer understands the key, that data cannot be unencrypted. So to encrypt it is to turn it into some gibberish. To unencrypt it is to turn it back to where it started. There are two types of encryption, secret key and public key. Which do you think is better? How many say secret key? How many say public key? You're right, it's public key. Secret key implies that two people, let's say Dhruv and I are communicating, we both know the key. It's our secret. What happens when two people know a secret? It's not a secret. Public key is what we know of as encryption. This is what companies do. So this is simple encryption. This is, just to make sure you understand what encryption is, you take a number, a letter, you convert it to its number equivalent, and let's just say we're just going to add 5 to every one, and now A becomes 6, the number 6. And so if you wanted to say the words "Hi, Abe," the A would be an F, and it would look like this instead. And then at the other side, it'll be de-encrypted to look like "Hi, Abe" again. That's encryption at the simplest form. Now let's talk about public key encryption. How many of you know what a prime number is? What's the definition of a prime number? A number you can only divide by 1 in itself. And by definition, a prime number can only be divided 2 ways, by 1 in itself. So 1 itself is not a prime number, because it can only be divided 1 way, by itself, which is 1. So prime numbers, 2, 3, 5, 7, 11, 13. Once you get past 2, there's no such thing as an even prime number, because it can always be divided by 2. And once you get, you could go 3, 6, 9, 12 forever and get rid of those. And you can go 5, 10, 15, 20 and get rid of those. 7, etc. So these are prime numbers. If I gave you the number 15, what are all the ways that what are all the factors of 15? Factors are, or prime factors of 15. 1, 3, and 5. And you could say another factor of 15 is itself, but we won't do that. 3 and 5 are the factors of 15. So the beautiful thing about prime numbers is if you multiply 2 prime numbers together, whatever number you get can only be divided, besides 1 in itself, can only be divided by the two prime numbers that created it. Okay? So if I gave you the number 77, what are the prime numbers that created that? 11 and 7. It's all very easy right now, right? Well, think about, there are people who are trying to figure out the biggest prime number ever, right? That's what they do for fun. The way this works is you have prime numbers that are hundreds of characters long, right? If you were to multiply two really long prime numbers, let's say this prime number has 200 characters and this has 150 characters. This one ends in a 1 and this one ends in a 7. I don't know what the numbers are, but they have a lot of characters in them, but they are prime numbers. There are some really big prime numbers. If you multiplied them together, you get a really big number that no computer in the world can figure out the two prime numbers from. That's the thing. In today's technology, you cannot figure out the numbers. No computer can figure out the numbers that make up a really large number that's the product of two prime numbers. So public key encryption is the product of these two prime numbers. And the only one who, let's say Amazon has encrypted, the only one who knows how to de-encrypt that is Amazon. They know the two prime numbers that made it, right? And it changes over time, so it's not like a person knows it, the computer knows it. It's, so when your information is being encrypted, it's being encrypted with this really long prime number, and it's only Amazon that can then take that and turn it backwards. And that's how public key encryption works. So it uses really big prime numbers. So these people who are figuring out big prime numbers, as computers get faster, those prime numbers are going to have to get bigger in order to be able to beat the speed of computers. Proxy servers. Almost every company has this. It's a server that sits between the internal computer environment and the internet. And it serves lots of purposes. So every time you go out to the internet, that computer is in the way. So every time that you're going to ESPN, that computer knows. And it's doing that for a few reasons. One, trying to create some efficiency. It'll store some frequently accessed information, so you don't have to go out and back as many times. Two, it'll limit your access. It can serve to prevent hackers from coming through. It's the first line of defense for hackers trying to come in. That's a proxy server. You have two different kinds of intrusion detection. Intrusion is a hacker trying to get in. There's passive and there's reactive. It's exactly what it sounds like. So a passive intrusion detection just logs things that look like they might be problems so that somebody can look at them and say, maybe we should have stopped that one. That was a mistake. And a reactive one is more powerful. If it sees someone who might be a problem, it just locks and gets them out immediately. Get them out, then we'll figure it out later. If they're meant to be in, we'll say, I'm sorry. Sometimes it's better to say I'm sorry than to allow the problem to happen. Log off a malicious user. Your firewall, your proxy server would trap any transactions that are trying to sneak through that shouldn't sneak through, that might have a Trojan horse in it or some other kind of software or problem, bug that you don't want to have. Everybody knows what an operating system is, right? Microsoft. What the operating system does is it controls your computer. Does any reading and writing to disk, reads your keyboard and knows what to do with it, controls what's displayed, manages your memory, etc. If an outside source gets control of your operating system, that's the worst case scenario. They could browse for information. They could go right into the core of your data. They could alter your data. They could change your access level so you can no longer get into your own computer. Change applications anywhere they want or destroy data, whatever their goals are. So your operating system needs to be most secure, which is why when any operating system comes in with a new release, it's a good idea to use it. Quite often they're putting in new changes to protect against recently found out problems. The second line of defense besides the operating system is your database management system. It sits between the outside world and the data, and it has controls in it as well, including authority tables. And then when you build your applications, you build in controls. So if you're building an accounting system, you build in your controls right into the accounting system. Some of the controls occur beforehand. You might want to make sure that your programs are authorized, tested, and approved before they go into production. So when you have changes go in, it's not just the programmer saying, hey, it's time, I feel like putting a change in. There's an authorization and a testing process outside of that programmer before it's allowed into the production environment. And you want to make sure that only the right people are using your computer system. Some of the controls that you'd have, you want to make sure that end users and management and potentially IT management authorize any changes, that you have the appropriate systems development lifecycle, and that testing was thorough and complete. Input control, some controls over the input that goes into an application system. Quite often you're typing it in yourself, but you might also be using it, some clerks might be typing it in from forms, paper-based forms. You want to make sure that your source documents are controlled in some way, that if you're doing a real-time input, that it's validated before it's accepted, and that if it's some kind of a batch process, you have control totals, etc. So a source document control, let's say this is the data entry for a new piece of inventory that you want to add to the system. It comes in on a form. It's old school. You need to have a supervisor signature. The form has a number that's sequential, much as we have auto numbering. In this case, it's auto numbered on paper, so that you're sure that it belongs in the environment. It's the next available inventory item, etc. If you're designing forms, which you all are doing, online forms, they must be logically organized and easy to use for the end user, so there's a less probability of a mistake. You might, if it's an important piece of entry, you might have to have an area where a manager authorizes it. Think about like if you go to the supermarket and you had to do something where they need to do something special, the manager has to come over and type in their initials or something or their code. We saw that they need to be pre-numbered or auto-numbered. And because they need to be pre-numbered and auto-numbered, you don't allow just anyone to get to blank documents if they're important. And of course, you'll have audit trails. Application controls, we know that you need to have validation checks. You're going to have them. It's in your metadata, right? It could be as simple as having the proper data type, numeric, text, date, whatever it might be. You might have a range test. It has to be between two values. Can't be any less than one if you're buying something, and you won't allow them to buy less than one item or more than 100. You have input masks to make sure the data that it's entered is the right length. You'll see that when you enter your credit card number. Might be a validity check. It only allows certain things, maybe the 50 states. You have to enter a real state. Valid combinations. You see that with credit cards. If it's a Visa, there's a certain numbering schema. If it's a MasterCard, there's a different numbering schema. Closed loop verification. Completeness tests. If it's an important field, make sure it's entered. Make it required. How many times you enter a bunch of stuff in when you're buying something and it doesn't go through, and then you got to search for the field that you forgot to enter. And in certain situations, you may want to put in default values so you don't have these null values in a field if a default value makes sense. In a batch world, you might have record. So let's just say you have a batch of payroll checks that you're producing, right? Twice a month, you produce payroll checks. You might have record counts, batch totals, or hash totals as a way of controlling that process. Record counts. You know you have 100 employees, you should expect to get 100 payroll records. If you got 101, you got a problem. If you cut 101 checks, that would be a problem, and you want to figure that out. So a record count is just each time you cut a check, you add one to a counter, and that total should be equal to what you'd expect. Batch totals, let's say it's that same payroll system. What's the most important field in payroll? The amount you're paying, right? Let's say you have this system, add up the amount you're paying. You might have a secondary system, or you might do it by hand, have an expectation of what you should be paying. So the batch total should match your expectation. So that's a batch total. It's a real number that is useful. It's similar but different to a hash total. What would be the least useful number to add up on a person's personal record? Social Security number, maybe, right? A hash total is you add up a completely irrelevant number, like everyone's Social Security numbers. You add them up. You get a number out of that. You compare that number to the number that the system gets. And that's a hash total. So a batch total is a useful number. A hash total is some irrelevant number. Okay? So that's how you might, in a batch world, make sure you have all the correct records in the batch. And then there's the check digit. You see a check digit used when you enter your credit card number. That would be the most logical place you'd see it. Let's just say American Express has a 7-digit credit card number. It doesn't, I know. And let's just say, by rule, the sum, when you add up all of the digits, all 7 digits, it's going to be some number. The ones column of that number has to be 4. Okay? So if you add this up, these are the first 6 digits. It's 1 plus 2 plus 3 plus 4 plus 5 plus 6 is 6, 10, 21. So what's this last digit going to be? 3. It's just one digit. It can't be 25. The last digit is a 3. Because if your number is 1, 2, 3, 4, 5, 6, 3, and you add them all together, 1 plus 2 is, plus 3 is, plus 4 is, plus 5 is, 15, plus 6 is, plus 3 is, 24. The ones column is a 4. And that's what they do with credit cards. So you'll know immediately if you've typed in a bad number, because you have a 1 in 10 chance, essentially, of typing in a bad number that's going to have that correct check digit. Some processing controls in the batch world. So if you go to a company, about 3 in the morning, you go into their computer area, there's an operator, maybe 2. You know, it's one of these lonely jobs. You work all night long, and you have all these programs that run at night, right? We've talked about the fact that even in an online real-time world, there's all these batch programs that still have to happen at night. And there's an operator who sits there and makes sure that these programs are running correctly. They're just watching a console, essentially like an air traffic controller. And that console needs to run through a formal schedule, and if there's a problem, and if you ever worked in an IT department, you'll get a call at 3 in the morning when your program is the cause of the problem. And usually somebody is responsible a different day of the week, so it's a little bit of a game of Russian roulette. You hope it's not happening on the day that you're responsible to wake up. And so that operator checks out to make sure that everything is going correctly. You need to make sure that everything's happening in the right sequence, that if you have to sort some of your databases in order to run the batch, that they're sorted in the right way. Each night you'll probably do a backup and recovery, or a backup of your data, and then send it off to Utah or wherever else you keep your backup files. And you'll produce any computer logs. So part of the processing controls of any company is this operator's console, this 24/7 function. Output controls, these are reports. Generally speaking, you want to make sure only the right people see the right reports. Sometimes there's very important secretive information on it that only senior management should see. So you might want to pre-number your reports to make sure that there are only 5 copies for these important reports and only the 5 people who should